My name is Spencer Mickus. It has been my dream since I was a kid to be a rocket scientist. I am currently a junior at Georgia Tech, majoring in aerospace engineering. Today, I will be talking about my favorite topic, rockets. A rocket, in its simplest form, is a chamber enclosing a gas under pressure. A small opening at one end of the chamber allows the gas to escape, and in doing so, provides a thrust that propels the rocket in the opposite direction. A good example of this is a balloon. Air inside a balloon is compressed by the balloon's rubber walls. The air pushes back so that the inward and outward pressing forces balance. When the nozzle is released, air escapes through it and the balloon is propelled in the opposite direction. When we think of rockets, we rarely think of balloons. Instead, our attention is drawn to the giant vehicles that carry direct-TV satellites into orbit and spacecraft to the moon and other planets. Nevertheless, there is a strong similarity between the two. The only significant difference is the way the pressurized gas is produced. With space rockets, the gas is produced by burning propellants that can be solid or liquid in form or combination of the two. One of the interesting facts about the development of rockets is that rockets and rocket-powered devices have been in use for more than 2,000 years. But the science of rocketry began with the publishing of a book in 1687 by the great English scientist, Sir Isaac Newton. Newton stated that there are three important scientific principles that govern the motion of all objects, whether on Earth or in space. Objects at rest will stay at rest, and objects in motion will stay in motion in a straight line unless acted upon by an unbalanced force. 2. Force is equal to mass times acceleration. 3. For every action there is always an opposite and equal reaction. These three laws of motion can be used to describe how rockets work. An unbalanced force must be exerted for a rocket to lift off from a launch pad or for a craft in space to change speed or direction. Newton's first law. The amount of thrust or force produced by a rocket's engine will be determined by the rate at which the mass of the rocket fuel burns and the speed of the gas escaping the rocket. Newton's second law. The reaction or motion of the rocket is equal to and in the opposite direction of the action or thrust from the engine. Newton's third law. As you can see, although the science behind how rockets work is extensive, the basics can be summed up simply. I am passionate about conducting research to further expand our ability to understand and explore space. I am very excited to start the next step in this journey by working at NASA's Hypersonic Propulsion Laboratory this summer. I'll be working on a project involving propulsion modeling and simulation for planetary exploration, developing technologies and concepts of atmospheric propulsion on other planets in our solar system. Thank you, and remember, sometimes it does take a rocket scientist.
Do you see them both light up?
Inside and shut down. Inside boosters.
Yes! Look at them.
What? Look at that. That's unreal.
Deployed.
And the Falcons have landed.
LZ1, LZ2, both side boosters.